Of the Chief Data Scientist, Melinda Han Williams.
Right, thank you. Can you see my screen?
We can, yep.
Okay, great. Okay, I'm Melinda Han Williams. I'm the Chief Data Scientist at Distillery, the AI ad targeting company. And today I'll share how we use AI for ad targeting at Distillery. And at its core, it's really simple. We use AI to learn the most we can, the richest, most in-depth view of a brand's customers. And we use that understanding to drive the best outcomes for the brand. So I'll tell you about this in 2 chapters. First, I'll dive deep into how we use multimodal AI for the richest understanding of the customer and the best predictions of their behavior. And second, I'll show the results when we use those predictions to go beyond binary targeting and drive even better outcomes. So first, the how. One of the most powerful aspects of today's AI is the ability to seamlessly learn from data across modalities. Whether that means AI that learns from video, radar, and GPS to get a coherent picture of the environment and drive a car, or AI that takes text as input and creates a realistic video as an output. Multimodal AI is so powerful because it can learn from any form of data and seamlessly apply that output to any modality of data. So at Distillery, when we talk about multimodal AI for targeted advertising, it means when our AI learns about the best customers for a brand, we build a coherent picture using different types of data, which means that our model is then fluent across data modalities and can work with any type of input or output data. So I'll show you what that looks like, starting with the type of data that we've seen over and over again drives the best performance for targeted advertising. And that's behavioral data. So if you think about language models like ChatGPT, they learn from language data by guessing the next word in a sentence for millions of sentences. Targeting models are really behavioral models. Their job is to understand and predict behavior, people's interests and interactions with a brand. The best way to learn about behavior is with behavioral data. So in the same way that ChatGPT learns language by guessing the next word, our AI model learns about behavior by guessing the next website in a journey from millions of journeys from opted-in digital panels. So the goal of this step isn't actually to predict what any one of these users will do. We do this to study the patterns in how real users visit these sites in order to understand each website's visit as a behavioral signal in terms of the intent behind that visit and what it tells us about that user's journey. So this creates an understanding of digital behavior that forms the core of our foundation model and also powers all our prediction. So here's a picture of how our model captures that understanding. And this is all real data learned from digital behavior. The green dots here are websites, and think of this like a map. So websites that are visited interchangeably with similar behavioral patterns will show up right next to each other on this map. So you see Wall Street Journal and Bloomberg.com. And then I added the label business news just for this slide. My model doesn't actually care about labeled category names. And that's because the positions in this space capture so much information. I'm showing this in 2D, but the full data the model looks at is in 128 dimensions. So each of these sites is represented by a 128 dimensional vector that captures what this visit means. So you've heard of embeddings as a thing that captures the meaning of words in a large language model. This is our embedding for digital behavior. Our AI has learned what a visit to each of these inventories mean based on how they're visited in real life, and that information is all captured here on this map. Now remember, we want the AI to learn as much as it can from every flavor of data in every direction. So we also bring in CTV data, and we can see the CTV activations that relate to those same little micro topics we saw for web behavior. We bring in data from mobile apps, and now we see in-app inventories that capture that same signal. And we even bring in search data, and we see real search terms people have typed into search engines and where those search queries sit on this map in terms of where they fit in a digital journey and what they say about the intent behind that journey. So we have this super rich, high-dimensional view that draws from all these modalities to build a map that captures the intent associated with each of these digital behaviors. Now, to make this really useful and actionable for targeting ads for a specific advertiser, we're going to bring in that advertiser's data. So this can be first-party data in the form of campaign conversion data or a pixel on a website. It could be proxy data that we work with you to build, or in this example, a CRM segment for a checking account signup. So a segment of users that has taken this action that the advertiser is trying to drive. Using that first-party data, we train a custom AI model specifically for this advertiser, not shared with any other brands, to find which impressions and which users have the highest propensity for taking that specific action. Now, because we've built this space that naturally connects web behavior and CTV and LLMs and search terms and more, the modeling process is natively fluent in all these different data modalities. So it can learn from data across modalities and also output the result in any form we need to seamlessly activate across every modality and channel. Now, with a custom AI model, every single user and every single impression gets a score that tells us the exact value of that impression to the campaign. The most common ways that our clients use a custom AI model is by activating a segment of users with the highest scores for that model at whatever scale the campaign needs. Or because this model can score impressions without any user IDs using inventory information alone. We also have clients activating contextual categories or curated deals that represent the highest scoring impressions across channels. But for those advertisers who want the best performance, because we know the value of every single impression, whether or not there's a user ID available, this approach lets us access a level of efficient performance that's way beyond traditional targeting. So the second chapter of my story is about how predicting the value to the campaign of every single potential impression unlocks an opportunity to move beyond binary targeting for massive performance improvements. Okay, so what's wrong with binary targeting? Traditional audience targeting recognizes that the brand has a message, they have a finite budget to share that message, so it's valuable to focus delivery on the people who are most interested and receptive and not waste your money on anyone else. And this is how ad targeting has always worked. The purpose of targeting is to allocate your ad spend, so this is a reasonable way to do it. Of course, we all know in reality, interest in any brand exists on a spectrum. So quantitatively, it looks like this. When you treat targeting as a binary, you reach the most interested people and you ignore everyone else. When you do that, you dedicate the same amount of ad spend to everyone who makes the cut and then zero to everyone else. So you're actually wasting money on lots of the people you reach, underspending on the most interested people, and completely missing out on all these other opportunities. If the point of targeting is to allocate ad spend, this is better than nothing. But we're talking about programmatic advertising, where every impression is bought in an auction. So with a custom AI model that predicts the value of each impression, you can allocate your spend way more efficiently, and that will drive way better results for the same budget. And it looks like this. Everyone is a candidate to see the ad, and they only see the ad if you can buy that impression for the exact value it's worth to the campaign. So if you're trying to run a campaign with a low CPA, it means you want a low cost per conversion. So you want a lot of conversions for a given budget. When you consider the pool of possible impressions you can buy, some are really likely to lead to conversions, some are less likely to lead to conversions. The insight here is that every single one of those impressions can drive the same low CPA if you buy it for the right price. CPA is what you pay per conversion, right? So the price you pay for an impression weighs exactly the same as its rate of conversion in terms of how it contributes to the CPA. So with this approach, we get way better results for the same budget because we pay more to capture the best opportunities. And we also take advantage of all the opportunities that were ignored by binary targeting, but only when we can buy those impressions for the exact right price to the campaign. It's a different way to think about targeting, and it drives super strong results. So here are the results. This is from a retail brand who ran our predictive bidding implementation of custom AI. And I'll compare the results to this baseline, which is cookie-based targeting. And we're looking at CPA, cost per acquisition, so lower is better. When we ran predictive bidding on just the pool of inventory that's also available to cookie-based targeting, inventory with cookies, but used predictive bidding for the decisioning instead of traditional binary targeting, it improved the CPA by 20%. And when we ran predictive bidding across all inventory, including inventory without IDs, which you can't do with traditional ID-based targeting, it improved CPA by 60%, which corresponds to 2.5 times more conversions per dollar compared to segment-based targeting. Because Distillery Custom AI predicts the exact value of each impression, whether or not there's an ID present, we're able to express that targeting intelligence through the bid price to go beyond binary targeting and unlock a new level of performance to drive the best outcomes for the brand. Thank you.
Awesome. Thank you so much.